This is 1-8, solving absolute value equations. Keep in mind that the absolute value is the distance a number is from 0. So in the first explanation here, they're talking about the numbers 4 and -4 both having an absolute value of 4 because they're both 4 spaces away from 0. If the absolute value of x is equal to 4, then x could have been -4 originally or 4, because if you plug in -4 into this spot, the absolute value of -4 is 4, but the absolute value of 4 is also 4. So therefore the solution set for the absolute value of x would be -4 and 4. Our solution set is placed in these braces. Since the absolute x could have been 4 or -4, I need you to know that absolute value equations will always have two cases that we need to consider. So one of them would be the positive and one would be the negative of that number, like we have -4 and +4. So let's look down at example 1 to see if this can make more sense for you guys. So for the absolute value of f plus 5 equals 7, our first case is where we're going to keep, equals 17, sorry. Our first case is where we're going to keep the 17 positive. In our second case, that 17 could have been negative. So if you just get rid of this whole f plus 5 for a second, what could have been in here originally was either 17 or -17 to end up with an absolute value of +17. So I'm making these two cases right now. I'm saying that f plus 5 could have been 17 or f plus 5 could have been -17. So you basically take what was in the absolute value bars, you write it with no absolute value bars, and you set it equal to a positive and negative number. And then we solve these as regular equations. So I'm solving for f, so I'm going to subtract 5 from both sides. I end up with f equals 12. On the other one, I'm going to subtract 5 from both sides, and f equals -22. So my solution set would be -22 and 12. I've also graphed my solution set with the closed circles here at -22 and 12. In example B, notice my absolute value bars are isolated, so I can go ahead and set up my two scenarios, but I want you to see something here. This b minus 1, what could have been in here, whatever number was in there, would have to result in a positive number. The absolute value of everything is positive, so this -3 can't be possible. So this is a no solution problem. You can never have an absolute value equal to a negative. This answer can't be graphed, and the solution set is no solution. In example C, absolute value of x equals 3. So we have two scenarios. We would have x equaling 3 and x equaling -3. And these don't need any solving since x is already isolated. So I can just go ahead and graph. Close circles at -3 and 3. In example 2, we need our absolute value bars isolated. So since I have this times 4 placed in front of the absolute value bars, I'm going to divide both sides by 4 before I set up my two cases. So now I have my absolute value bars isolated, and 24 divided by 4 is 6. Since that 6 is positive, I can go ahead and make my two cases. X plus 2 equals 6, and x plus 2 equals -6, and I can solve both by isolating x. 6 minus 2 is 4, and x equals -8. So I have 4 and -8. Sorry, I'm going to go back for a second. I didn't write my solution set for example C. So my solution set for example 2 would be 4 and -8. Okay, in example 2b, again, I need to isolate my absolute value bar. So I have this positive 2 in front. I'm going to subtract 2 from both sides. That gives me negative absolute value bar. 2x minus 5 equals 7 minus 2 is 5. Divide both sides by negative 1, or to get rid of that. It's really a negative 1 in front of the absolute value bars. So divide it by negative 1, I get absolute value of 2x minus 5 is equal to negative 5. There's no way an absolute value could be equal to a negative, so my solution set here is no solution. Okay, in example 2c, same thing again. I'm going to isolate my absolute value, so I'm going to add 6 to both sides. And I end up with absolute value of x minus 4 is equal to 0. I don't need that plus in front, just representing a positive absolute value. And since it's equal to 0, it's not negative or positive, I can't really make two cases. I just end up with x minus 4 equals 0. And I solve that, add 4 to both sides, and x is going to equal 4. The only number that could be placed into those absolute value bars would be 4. And so that's my whole solution set. So just to recap so far, if you have an absolute value equal to a positive number, you're going to have two solutions. If you have an absolute value equal to a negative number, absolute value can never result in a negative number, so that would be no solution. And if you have an absolute value equal to 0, like we just had, we only had one solution in our solution set. Let's look at the word problem for example 3. The temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit, give or take 5 degrees. Write and solve an absolute value equation to find the maximum and minimum temperatures. Okay, so the first thing I want you to recognize is that x is going to represent the maximum and minimum values. Give or take 5 degrees, the difference we can go up and down, I put equal to this equation. So now I can write my two cases. I have x minus 80 equals 5 and x minus 80 equals negative 5. Solve for x. And 85 or 75 is my solution set. And this makes more sense now if you think back. So the temperature of an enclosure for a pet snake should be about 80 degrees, give or take 5 degrees. Well, if you have 80 degrees and you give or take 5, you're talking about giving it 5, which would add to 85. We're taking 5 away, which would be 75 degrees. So anywhere, any of those degrees are acceptable for the temperature of the enclosure for the pet snake. In example 4, we want to know really what number was between 11 and 19, which is 15, to know how many we're giving or taking here. So 11 to 15 is 4, and 15 to 19 is also 4. So if you think back to the word problem we just did when we had equal to 5, that's what we were giving or taking 5. So in this case, we're going to be equal to 4. And our original number was 15. And so if you take x minus 15, absolute value equal to 4, you'll see that this works. So I'm just going to solve this so we can see what I mean here. X minus 15 equals 4. Here's my two cases. X minus 15 equals negative 4. Solve both of these scenarios. X is equal to 19 and x is equal to 11. So try example 4b, knowing that, pause it, and then I'll show you how to do it. Okay, so I found my middle number, which was 22, and I see that this is give or take 5. So my absolute value is going to be equal to 5, And I'm going to have x minus 22 in order to find my max and min number. And I can check this like I did in the last problem. So I'll make my positive case positive 5 and my negative case negative 5. And I can solve these by adding 22 to both sides. And I get 27 and 17 as shown on the graph.